In this video, I'm going to show you how to process data for a correlational design. A correlation is a type of research method that allows researchers to investigate the relationship between two variables. You may hear these referred to as predictor and criterion variables. However, we don't need to worry too much about that because a key characteristic of correlational designs is that there is no independent variable. Therefore, you can plot either variable on the x or y axis. Because there is no independent variable, there is no variable that the researcher is systematically manipulating to determine whether this has an effect on another variable. Therefore, causation cannot be inferred. However, correlations are very helpful in order to predict the outcome based on changes to one variable. As with any statistics, there are assumptions that we need to check before we can carry on. The first one is to make sure that our level of measurement is interval or ratio data. This will allow us to calculate mean and standard deviation, as well as a Pearson correlation coefficient. If we had other types of data, such as ordinal, then we would be calculating median, interquartile range, and a Spearman correlation coefficient. I will circle back to normal distributions. So here we have some sample data. Imagine that we collected information on participant gender, their age, sugar consumption, and activity levels. The research question we want to answer is, well, what is the relationship between sugar consumption and activity level? Now, we always want to summarize the demographic information of our participants. So down here, I've got the statistics we want to calculate, the variables that we have measured, and then I'm showing you what the Excel formulas could look like. Please note that these numbers between brackets would change depending on our data. So the first thing we want to do is we want to count the number of participants in each condition or for each variable. In Excel, whenever we want to calculate something, we need to start with an equal sign. Then we need to give Excel the name of the function. In this case, I want Excel to count. Now you can choose count or count A, it's not really going to matter. So let me show you what count looks like. You'll see that Excel prompts me with an open bracket to enter the values that I want to use to count. So instead of entering each one individually, we're just going to click and drag our first column, and you'll see that Excel is now taking column E from rows 5 through to 17. I can now close the bracket and hit enter, and there you go. We have 13 participants in this first column, and if you wanted to, you could check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So while you could manually count the number of participants, imagine if you had 30, 50, 100, or even thousands. You could see why using a function in Excel makes a lot more sense. Now we can repeat that process for our second variable, or we can use this handy feature in Excel where we can copy a formula into a new cell. To do that, what we need to do is try and select that corner and drag it across, and you can see that Excel has now used the data from our second column to calculate the number of participants. And I'm just going to change the color so that it matches the rest. All right, now we want to do something a little bit trickier. We want to count, but only specific information. To do this, we need to use a countif statement. So I'm going to start with an equal and type in countif. If I click on this, you'll see that Excel prompts me I need to enter the range. In other words, what is the information that I want Excel to use? So now I'm going to come over and select my data. The next thing is Excel prompts me for the criteria. So I'm going to enter a comma and then put a capital F in quotation marks. This is telling Excel that in this range here, I want you to count how many times capital F appears. If we now click enter, you'll see that in our data, 7 of the participants identified as female, which means that the remainder, 6, must have identified as male. We can use Excel to calculate percentages, start with an equal sign, and now we need to divide the part by the whole. In other words, divide the number of females we have and divide it by the total number of participants. If I click enter, I am going to get this value here. If you don't get a percentage, it could be because this was set to number, which would give you a decimal. To make sure you get a percentage, just click on this percentage symbol. All right. Now we want to summarize our data by calculating the mean and standard deviation. For mean, we're going to use the average function, and standard deviation, we use this function stdev. As always, start with your equal sign, type in the function, and then give Excel all the data it needs to use to be able to calculate the average. I'm going to close my bracket and click enter, and I'm going to repeat the same for standard deviation. There you go. We now have the mean and standard deviation for age. But again, I don't want to do this manually every time, so I'm going to just point my mouse at this little square here and I'm going to drag it across, and Excel is going to automatically adjust those formulas so that it calculates the average for the column above. So you can see it shifts it along. And then I've just changed the coloring so that you can see which variable it belongs to. Now, we want to calculate a correlation coefficient. Correlation's coefficients give us the strength and direction of the relationship between two variables. To do this, we enter equal and start typing in correl for correlation. Click on that and you'll see that Excel prompts you to enter the values for array 1. Array is just a selection or collection of data. So what I'm going to do is select all the data in my first variable. I then need to separate that by entering a comma, and now I can select all the data in my second variable. Close the bracket, and there you have it. Our correlation coefficient is a positive 0.73. Correlation coefficients are values between 0 and 1, where 1 is a perfect relationship and 0 is no relationship. Therefore, the closer this decimal is to 1, the stronger the relationship. Because the sign of this correlation coefficient is positive, because there's no negative sign, it means that we have a positive relationship. For more information on how to interpret correlation coefficients, please see the additional video in QLearn. Lastly, we need to calculate something called a p-value. A p-value is the probability of getting this correlation coefficient. To do that, unfortunately, we need to go to another website. That is because it's not as straightforward to calculate a p-value in Excel. So if you click on that link, it'll take you to Social Science Statistics, and you can see that we want to calculate a p-value from a Pearson R. To do that, we need to enter our correlation coefficient, which was 0.73. The number of participants was 13, and we're going to set our significant level to 0.05. Then simply hit calculate, and you'll see that it tells us our p-value is 0.004612. I'm going to copy that and then paste it back into Excel. Typically, we report these to no more than 3 decimal places, so I'm going to round this to 0.005. Let's just make that additional. There we go. So now we have calculated all the statistics that we will report on. The next thing we need to do is create a scatterplot. A scatterplot visually represents the relationship between two variables. The easiest way to do this is to simply select your 2 columns, and I would include the headings here. Go to Insert, and you want to navigate over to your chart where you can see this one is XY scatter, and choose the first one. I'll just move this down. There we go. All right, this makes it a little bit hard to see, so we need to figure out what our axes are and make sure that we enter some titles. To add axes, simply come up here to chart elements. We want axis title on both the horizontal and the vertical axes, and you'll see that it enters this here. To know which one's which, just look at your data. So sugar consumption had much lower values than activity level, and we can see that the scale on the x-axis is much lower. So here I will put sugar consumption, and I will name my y variable, or y-axis, activity level. One more thing we need to add to our scatterplot is a line of best fit so that we can see whether the direction is positive, negative, or none. To do that, go back to your chart elements, add a trend line, and select linear. And now we can visually see that our line of best fit starts low and ends high, which means as our sugar consumption on the x-axis increases, there is a corresponding increase in our y-axis. Therefore, there is a positive relationship between sugar consumption and activity level. This is verified by the positive correlation coefficient value that we have here. Additionally, we can see that these scatter plots are fairly close to our line of best fit. The closer these dots are to our line of best fit, the stronger the relationship. Lastly, we need to check our assumption that normal distribution or normality is met for each of our variables. To do that, we need to create categories. These categories, just look at what your lowest and highest values are, and then simply group your numbers into categories that fit that range. Try and aim for odd number of categories. Then for each category, simply go and count the frequency of the values within that category. So for example, I have a number 1 and a number 2, and that's it. Which means for the numbers between 1 and 3, I have 2 values, or a count of 2. Next, go and look at how many numbers you get between 4 and 6. Here we will see that we have 1 5 and 1 6, so our count for that category is 2. And so on. There is no exact science with the categories. You just want to make sure that each category is the same size and that you cover the full range of your data. Once you have categories for both your variables, you simply want to create a column graph. So once again, select both your data points, including the headings. This time we're going to insert and we're going to choose a column graph. So you'll get something like this, and because I selected my heading, it already says that this is my count, or let's call this histogram for sugar consumption. Now a histogram means that we have continuous data, so when you double click on your columns here, you will get the following data box. I'm going to reduce my gap width to 0. I'm going to come to this little paint bucket. I'm going to make my fill a bit lighter so that I can more easily see the boxes, and I'm going to set my border to something a bit darker. Okay, so now you can see that we have a histogram. Arguably, it's not entirely normal, but it's good enough for what we're doing because we can see that we have a peak and that it drops down to both sides and there's not a particularly long tail. Let's repeat this process with our other category. Once again, I'm going to rename this to histogram. I'm going to select both columns with data, insert, column graph. Once again, we need to make sure that this looks like a histogram, so we're going to select our data, come to this one that looks like a graph, make the gap width 0. Click on the paint button, make your fill something a little bit lighter, and make your border nice and dark. Okay. Once again, this is roughly a normal distribution. We have a peak in the middle that drops off on each side. We don't have a massive range, and so we could argue that this is reasonably normal, or at least it is good enough for us to be able to calculate a Pearson's correlation coefficient. And that's it. Good luck with yours.